Welcome to two examples of factoring using the method of substitution. When an expression resembles the form ax squared plus bx plus c, we can use the method of substitution to try to factor the expression. Looking at the expression ax squared plus bx plus c, notice how the variable factor of the middle term is x, and if we square x, we get the variable factor of the first term, which is x squared. The expressions need to fit this form in order to use the method of substitution. Our first expression is x raised to the power of 2/5 plus 3x raised to the power of 1/5 minus 40. Notice how the middle term has a variable factor of x raised to the power of 1/5. We need to verify if we square x raised to the power of 1/5, we will get x raised to the power of 2/5. So if we have x raised to the power of 1/5 and we square it, notice how we do get x raised to the power of 2/5, because when we have powers raised to powers, we multiply the exponents. So let's write the given expression as the square of x raised to the power of 1/5 plus 3 times x raised to the power of 1/5 minus 40. By writing the expression in this form, we verify if it's the form we need, and it also helps perform the substitution. We now introduce a new variable and set it equal to the variable factor of the middle term. So for this example, let's let u equal x raised to the power of 1/5. And now we write the expression in terms of u. Because u equals x raised to the power of 1/5, we can now write the expression as u squared plus 3u minus 40. We now factor this in terms of u and write it back in terms of x. And again, this is a u. If it does factor, it will factor into two binomial factors. Because the first term is u squared, which equals u times u, we have a factor of u here and a factor of u here. Because the leading coefficient is 1, we now need to find the factors of negative 40 that add to positive 3. Because the sum must be positive, notice negative 5 times positive 8 is equal to negative 40, and negative 5 plus 8 is equal to positive 3. The two factors we need are negative 5 and positive 8, which means one factor is u minus 5, the other factor is u plus 8. And now that we have it factored in terms of u, we write it back in terms of x using u equals x raised to the power of 1/5, which means one factor is x raised to the power of 1/5 minus 5, and the other factor is x raised to the power of 1/5 plus 8. This is the factored form of the given expression. And now let's take a look at our second example, which is a little bit different. Notice how we have the quantity x minus 3 squared minus 7 times the quantity x minus 3 plus 12. While we could multiply all of this out and then factor, let's use the method of substitution. Looking at this product here, notice how we have one factor of x minus 3, and then here we have two factors of x minus 3. So let's let u equal x minus 3 and perform substitution. If u is equal to x minus 3, we can now write the square of x minus 3 as u squared, and then we'd have minus 7 times u plus 12. And now let's factor this in terms of u and write it back in terms of x. If this does factor, it will factor into two binomial factors. Because u times u is equal to u squared, we have a factor of u here and a factor of u here. Because the leading coefficient is 1, we need to find the factors of positive 12 that add to negative 7, which are negative 4 and negative 3. Notice negative 4 times negative 3 is equal to positive 12, and negative 4 plus negative 3 is equal to negative 7. Which means in terms of u, one factor is u minus 4, and one factor is u minus 3. But now we need to write this back in terms of x. Remember, u is equal to x minus 3, which means we can write the factor of u minus 4 as the quantity x minus 3 minus 4, and we can write u minus 3 as the quantity x minus 3 minus 3. But now we should simplify the two factors. X minus 3 minus 4 is equal to x minus 7, and x minus 3 minus 3 is equal to x minus 6. This is the factored form of the original expression. And again, we factored this using substitution rather than multiplying all of this out and then factoring. I hope you found this helpful.